going to start chapter 2. This section will not be on your test, but it's something super easy. It's just a quick review of slope and the different forms of the equations of the line. And it's also graphing. So you will need a graphing calculator in chapter 2. So if you have not purchased one, make sure you get one before we get too deep into chapter 2. So the first thing we're going to do is talk about the three different types of equations. And these are all for linear equations. You have slope-intercept, which a lot of you know as y equals mx plus b, where the m represents the slope and the y-intercept is the b. When you're entering this on WebAssign, you're going to enter the y-intercept as an ordered pair. So the y-intercept is always going to be an ordered pair with a 0, comma, and then the point or the number where it hits the y-axis. Point slope form is y minus y1 equals m times x minus x1, where the y1 and the x1 in this formula are just going to come from a point that they give you. So you're going to be filling in an ordered pair here. And then the last form is the standard form, and that's ax plus by equals c, where a, b, and c are just numbers. They cannot be fractions or decimals, and the first term or the coefficient in front of x must be positive. So in examples of these three types, could be intercept, could be y equals 2x plus 5. Or it could even be fractions, y equals 2/3 x minus 1/2. So that's slope-intercept. Point slope, it'll just have y minus, and then it'll be a number, and then the slope, and then x minus a number. That's point slope. Standard form could be 2x plus 3y equals 4, where a, b, and c are just going to be integers, but a cannot be a negative integer. Let's look and see what the slope formula is on the next slide. So the formula, remember it's the change in y divided by the change in x. It's also known as rise over run. So what you're going to do is subtract the two y coordinates on the top of the fraction and then the two x's on the bottom. So you'll be given two ordered pairs. And again, think of these little numbers at the bottom as like labels. X1, Y1 is like ordered pair number 2. X2, Y2 is like ordered pair number 2. And you just plug it into the formula. The biggest mistake I see with students doing slope is they forget to put the y on top. So just remember, the y's go on top, x's go on the bottom. To find an x or a y-intercept, what we're going to do is substitute in zeros. So if you want to find the x-intercept, you're going to plug in 0 for y. And that is going to be where our graph intersects the x-axis. For the y-intercept, we're going to replace x with 0 and solve it. And that's going to be where our graph intersects the y-axis. Trick or something that a couple years ago, one of my students told me, the way that their middle school teacher told them to remember the slope formula is you're planning on having a picnic on the side of a mountain. And there's no tables or anything, and you didn't bring a blanket, but you have stuff to build a picnic table. So what we're going to do is we're going to use the x's as the legs or the base of our picnic table. So that's where the x's are going to go. And on our picnic, we're going to serve some Yum Yum juice. And we like to serve our Yum Yum juice in glasses that look like Y's. He actually said that they were, I guess, martinis, but we're going to call it Yum Yum juice. And then just know that you would subtract the y's and subtract the x's. So just remember the base of your table is the two x's, and then the top is where you're putting your glasses. Whatever trick's going to help you, just remember you subtract the y's on the top, subtract the x's on the bottom of the fraction. Now let's talk about slope and what it looks like. So two special cases is when the line is a vertical line, the slope is undefined, or you have no slope. When you're going to enter this in WebAssign, in the problem, they're going to tell you when it's a no slope or if it's undefined, you're going to type in the 3 capital letters D, N, E. Does not exist. So when you get a slope that is undefined, when it's a vertical line, you're going to type in DNE. The same thing's going to happen when there's no y-intercept. Anytime there's none, you're going to type in DNE. Okay, and then for a vertical line, the equation is always going to be x equals a number. There is not going to be any y in the equation. Now, a little trick to help you remember that a vertical line, the slope is undefined. When I graph a vertical line and you're looking at it, it looks like the line is going up and down. And if I take out the u from up and the n from down and the d from down, or the n from and the d from down, it's starting to spell the word undefined. So if I were to graph, let's say I give you an example. Let me draw a coordinate plane over here, or just an x and a y axis. This is my x-axis. This is my y-axis. If I ask you to graph the line y equals 3, oh wait, I'm going to do x equals first. Sorry, x equals 3. That's the equation for the vertical line. So I would come over here to 1, 2, 3, and it's going to be a vertical line through the x-axis at positive 3. So that would be the graph of x equals 3. Notice my slope, when you key this into WebAssign, my slope is going to be DNE. My y-intercept, notice it does not touch that y-axis, so the b here would also be DNE. So when it's a vertical line, unless it's x equals 0, it's not going to have a y-intercept, and it does not have a slope. So notice when you look at the blue line, you see how it looks like it's going up and down? So that is the undefined slope. Another thing, the horizontal line, this has a slope of 0. It's a flat line, and this will be y equals a number. There will not be x. So let's say I want to graph y equals -2. So I would come over here to -2. It's going to be a horizontal line through -2. And that would be the graph there. So the slope you would enter would be 0. And your y-intercept, or your b, you're going to enter it as an ordered pair, and it'll be 0, -2. So that is your y-intercept, or your b, when it's a horizontal line. Now, when you're doing the slope formula, you're going to be subtracting the two coordinates, and when you subtract them, when it's a horizontal slope, what's going to happen is, after you do this formula, y2 minus y1, x2 minus x1, for the horizontal line, you're going to get a 0 on the top, and then the bottom will have a number. So when this happens, this fraction simplifies to 0. For the vertical line, what will happen when you plug it in? y2 minus y1 over x2 minus x1. You're going to get a 0 in the denominator. So what will happen here is, this is undefined. We can never have a 0 in the denominator. So this is why you would write DNE. So when you're plugging and you're given two order pairs in the homework, if you get a 0 in the denominator, you're typing in DNE. If you get a 0 in the numerator, you're going to type in 0. So you probably graphed back in your Algebra 1 class. It's usually easiest to graph by putting it into y equals mx plus b. Remember, when it's in that form, try the first one. So the slope is rise over run. The y-intercept, that b, is our beginning point. So if I were to graph this first equation, I'm going to begin on +1 on the y-axis. From there, I'm going to move my slope. So I'm going to rise up 2, and I'm going to run to the right 3 spaces. So I'll put my first point on +1, and I'm going to do this whole graph here in red. So I'm going to graph all of these on the same graph. So I'm going to put my first point on +1. From there, I'm going to rise 2. So you're going 1, 2, and then you're running over to the side, 1, 2, 3. So I'm gonna get rid of all those loops because I don't need them. Remember back from your geometry days, technically all you need are 2 points to create a line. You could keep repeating the rise and the run to get a more precise line. What's nice about Notability, you could just hold down your stylus and it makes a nice straight line. I am not in Notability, so my line might be a little wiggly here. So I'm gonna add a couple points just so I can connect them a little bit better. So you can keep repeating it if you wish, and then connect your points and graph your line. Remember, a line extends forever in both directions. You would add arrows to the ends. The next one, same thing. Now, another thing to keep in mind is when your slope is a positive number, it's going to rise from left to right. When it's a negative number in front of that x, it's going to fall from left to right. So for the next one, my beginning point is the same place. It's at positive 1, but now my slope is negative 4 over 1. So I'm going to go down for my rise 4 units, and I'm going to still run to the right 1 unit. You could also go up and left. One of the movements needs to be negative. So I'll go ahead and put my first point on positive 1. And again, I'm going to go down 4 units, 1, 2, 3, 4, and over to the right 1. If you want to go up and left, you can. And then connect your points. And again, notice it's a negative slope, so it's falling from left to right. So that one is in blue. I'll do the next one in black. Now, this one is not in slope-intercept form, so we can rearrange it. Now, you can also graph by finding the x and the y intercepts. And I'm going to show you this one both ways. So if I just want to put this equation into y equals mx plus b, I'm going to divide both sides by 3. And I get y equals 2/3 x minus 1/3. Now, notice my y-intercept is a fraction. Okay, so I'm going to have to move it from between thirds. So I'm going to start here at negative 1/3, and then I'm going to rise to run 3. Now, again, my graph is going by ones, so just approximate it. So this one I'm doing in black. So about negative 1/3 would be maybe around here. So I have to rise 2. So I'll go up to the next 1/3, or like 2/3, and then go up 1, 2, and then I go over 1, 2, 3. So somewhere over in here. So again, as long as it's close, I'm not looking for too much precision here. And then I could go down. And I can connect my line. All right, so that was the next one. Now I'm going to also show you how you could have found the x and the y intercepts. Another way to do that. So here was my equation. It was 3y equals 2x minus 1. I could rearrange this and put this into standard form. So I could move the 3y over. 0 equals 2x minus 3y. And then I got to move the 1 over. So now I have 1 equals 2x minus 3y. Let me flip it around. So now it's in standard form. Remember, the number in front of x has to be positive. Now, back when I used to teach Algebra 1, I would teach my Algebra 1 students a trick called cover-up. So essentially what we're doing here, the official way, is if I want to find the y-intercept, I am setting x equal to 0. So I would plug in 2 times 0 minus 3y equals 1. This just goes away. And then 3y equals 1. Divide by negative 3. And my y-intercept is negative 1/3. Again, written as an ordered pair. And we already knew that when I put it in y equals mx plus b. To find the x-intercept, I'm setting y equal to 0. So 2x minus 3 times 0 equals 1. 2x equals 1. Divide by 2. And my x-intercept is 1/2 comma 0. Now, what you can do is take these two order pairs and graph them, this one, and then connect the 2 points. So let's see how close I came when I graphed this. So I said it should have been about 1/2 comma 0 and 1/3. And then you would just connect the points. Now, when I used to teach it to my Algebra 1 class, instead of showing them officially to plug in the zeros, as long as it was in standard form, I would tell them to do this. If I wanted to find the y-intercept, I would pretend like this wasn't there, and I would solve what was left. When I wanted to find the x-intercept, I would cover up the y term and then solve what was left in the problem. So here you divide, here you divide, and then that's how you get the negative 1/3 and x equals 1/2. This only works when it's in standard form. So this is another technique of graphing. Other than putting it into y equals mx plus b, you can find the intercepts. So another way to graph. Let's go back and finish up the graphs. So the next one, notice this one is y equals a number. It's going to be a horizontal line. I'll do this one in pink. I need to first get y by itself. Notice there is no x. So when I go to do this, I'm going to be graphing 1 2/3. And again, remember, it is going to be a horizontal line through the y-axis at 1 2/3. So if I just come over here, I'll say 1 2/3 is maybe about here. And then just draw your horizontal line. And then the last one will be a vertical line. And let's see if I can get another color here. Let's do maybe purple. Okay, so divide by 2. Oh, it looks pink again. All right, x equals 1/2. So this is just going to be a vertical line. Maybe I can do it in green. Green shows up. All right, so it'll be a vertical line through the x-axis at 1/2. So it'll be right through here at the 1/2. So if they ask you to key in the slope for this, the slope of this line, remember when it's vertical, you would type in DNE. For the y-intercept, you're going to type in also DNE, because notice my green line never crossed the y-axis. Let's try some more examples. So here you can do two things. You can either find the intercepts and then graph the intercepts and connect them, or put it into y equals mx plus b. It doesn't matter. So if you're accustomed to, see, this is already in standard form, except for this can't be negative. So you'd have to divide everything by -1. But I'll just go ahead and put it into slope intercept. I'm going to add 3x to both sides. 3x plus 6, divide by 2, and y equals 3 over 2x plus 3. So your slope would be, if they ask you to enter it, 3 over 2. Your y-intercept, again, as a coordinate, would be 0, 3. So I'll come over here, put my first point on +3, and then from there, move the slope, which I'm going to rise 3 and run 2. Let's put your first point here on 3. Rise 3, run 2. So 1, 2, 3, 1, 2. So my final point is right there. Connect them. And graph your line. Number 7, we're going to do the same thing. Now, notice my y isn't by itself. I could go ahead and find the intercept. Let's do the intercept on this one. I'm going to add 3x. I'll get it into standard form. Actually, let's put the 3x first. So 3x plus 2y plus 3, then move the 3 back over. So now negative 3 equals 3x plus 2y. So 3x plus 2y equals negative 3. Again, if I do my cover up to find my x-intercept, cover that one up. So now I'm solving 3x equals negative 3. Divide by 3. X equals negative 1. So my x-intercept is 0, negative 1, or negative 1, 0. Then to find my y-intercept, I'm going to cover up the x. And then I solve what's left. So I divide by 2. And the y-intercept is at negative 3 over 2, or 1.5. Negative 1.5. So order pair. So I'm going to put my first point on, or I'll put an order pair at negative 1.5 on the y-axis. Then I can also graph negative 1, 0. And let me do this one in red. And then here is the x-intercept, and then connect the points. Number 8, add the 1. 4x equals 6. Divide by 4. And x equals 3 over 2, because I can reduce 6 over 4. Remember, when it's x equals a number, when it's a vertical line, the slope is undefined, so it's DNE, and so is my y-intercept. So I'm going to draw a vertical line through 1.5. So 1.5 vertical line going right through here. Then the next one, I can go ahead and put it into y equals mx plus b. I'm going to get rid of my fraction. So I'm going to multiply everything by 3. So then this becomes 2x plus 12y equals 21. Move the 2x. 12y equals negative 2x plus 21. Divide everything by 12. So it's y equals negative 1/6 x. And then I could reduce 21 over 12. I can divide them both by 3. 7 over 4. So this one's a bit challenging, yes. Yes, you could have. Absolutely. Yep. So if I did that, if I did number 7 into y equals mx plus b, negative 3x equals 2y plus 3. Move the 3 over. Negative 3x minus 3 equals 2y. Divide everything by 2. And then let me just rearrange it. So y equals negative 3 over 2x minus 3 over 2. So the slope here is negative 1.5 or negative 3 over 2. Actually, I'll leave it a fraction so I can do the rise and the run. So the slope is negative 3 over 2, and the y-intercept is the order pair 0, negative 3 over 2. Absolutely. All right, so I have to graph this crazy one. So 7 over 4, remember this is really 1 3/4. So what I'm going to do is, this is where my first point's going to go, but then I need to rise up 1 from that and then run to the, I'm going to go down 1 because it's a negative slope, and then from there run to the right 6. So first point is at 1 3/4. So about there. So then from there, because it was a negative slope, I'll go down 1. And then I'm going to run to the right 6. So I can put my first point there. and then just connect them. And then the last one, again, let's put it into slope-intercept form. I'll just divide everything by 3, -3. Remember all 3 parts. So negative divided by a negative becomes a positive 2/3 x, and -1 divided by -3 becomes a positive 1/3. So my first point will go on 1/3. So if it asks you to identify the slope, it's 2/3. The b would be 0, 1/3. So my first point, let me go ahead and switch colors here. Let's see if I can get a different color here. Maybe orange. There we go. Let's try orange. All right, so I'm going to start on 1/3, and then from there I'm going to rise 2, run 3. So on 1/3, so about here, then I'm going to go up 2, and then run to the right 3. And again, because this isn't going by tenths or I don't have fractions on my graph, get it as close as you can. On WebAssign, same thing. All right, so that is graphing. Again, you can either find intercepts or you can put them both in, or put everything into y equals mx plus b. The last part of it, we're just finding the slope. So when your equation is already in y equals mx plus b, remember the slope is sitting right here in front of x. So the slope here is 3. For number 12, we got to work for it. We got to put it into y equals mx plus b form, or at least attempt to 2y equals 6, divide by 2. Remember, whenever it's y equals a number, this is a horizontal line, so my slope equals 0. My y-intercept, if they ask for that, would be 0, 3. This graph, remember, is a horizontal line whenever there's no x here. Number 13, now we're given 2 coordinates. So we're plugging it into y2 minus y1 over x2 minus x1. I'm going to say this is x1, y1. It doesn't matter. You get the same answer either way. So if I do 7 minus 3 over 4 minus 4, notice you get a 0 in the denominator. This is undefined. On WebAssign, you're going to key in D and E. On the test, when we get to the Chapter 2 test or quiz, if you don't simplify this fraction and tell me that it's undefined, you get it wrong. You have to be able to simplify and know what to do with the 0. 14, I'm going to put it into y equals mx plus b. I'm going to get rid of the fraction first. So I'm going to multiply everything by 3. 6y equals 2x minus 3. Divide everything by 6. And y equals, I'm going to simplify 2 over 6 to 1/3. And simplify 3 over 6 to 1/2. So my slope here is 1/3. And my y-intercept is 0, -1/2. $15, we're going to do the same thing. We're going to get it into y equals mx plus b. And then 16, we're going to do the slope formula. So for 15, I'm going to get it into y equals mx plus b. 3y equals -2x plus 5. Divide by 3. And y equals -2/3 x plus 5/3. So again, my slope here is -2/3. My intercept is the order pair 0, 5/3. Number 16, slope formula, y2 minus y1 over x2 minus x1, 0 over -1. Whenever the 0 is in the numerator, the slope is 0. This is a horizontal line. So remember, when it's y equals a number, it's a horizontal line, and when you do the slope formula and the zeros in the top, it's also a horizontal line. 4 more examples, same thing, put it in the slope-intercept form and do the slope formula. So let's try 17, 18, 19, and 20. It is a typo on these last two. These should be 19 and this should be 20. So I'm going to move the 3x over. 4y equals negative 3x plus 5. Divide everything by 4. Slope is negative 3/4. Y-intercept is the 5/4. Again, write it as a coordinate when you enter it into WebAssign. 18, I'm going to do the slope formula. Y2 minus y1. So again, label them. It doesn't matter. You get the same answer even if you flip-flopped it. 5 minus 2. 4 minus negative 3. Be very careful with your integers. You got to do a keep flip change here. So that's how I got 7. Number 19, add the 1. 3x equals 6. Divide by 3. X equals 2. Remember, when x equals 2, this is a vertical line. So my slope here would be dne. It's undefined. And then the last one, slope formula, negative 5 minus negative 2 over negative 3 minus negative 1. Negative 5 minus 2 is really negative 5 plus 2, negative 3 plus 1. This gives me negative 3 over negative 2. Remember, a negative divided by a negative gives me a positive 3 over 2 slope. And you're done. That's it for slope. So again, this should have been a nice little review of your linear stuff, the 3 types of forms of linear equations, as well as the slope formula and graphing.